10.2 Forces and Vectors. We'll discuss one example first. So there's a 3 Newton force in this direction, and this is OX direction, and 4 Newton force in OY direction. Now, which direction this particle will move, and what is the magnitude of the resultant forces? So resultant force. So it is very clear that we will complete the 3n and 4n. This is the triangle completed, and we can find the resultant forces are, let's say, are by Pythagoras 3 square plus 4 square, the square root 9 plus 16 is square root, that is 5. So now this is the resultant force R. Assume this angle theta with the x-axis. So now I want to find theta. Tan theta is, this length is 4, this is 3, 4 divided by 3. Theta is tan inverse 4 divided by 3. So this R forces, actual R forces, R force with the size 5 Newton with this angle theta is represented by 4 and 3n. So here this R represented by 3 and 4. So we have to easily, we can write 3i plus 4j. So this R. Now I'll give R equal 3i plus 4j. What is the idea behind this one? R, the OX component is 3 Newton, and OY component is going to be, okay, horizontal component or vertical component is 4 Newton. So R is this one? No. R is this one? No. R is this 5 Newton. We found out now. Easy calculation. We break R into horizontal and vertical. What is the real force for this one? So if you draw a particle, and this is R, is 5 Newton to theta. So tan theta equal 4 by 3. Y divided by x, 4 by 3. Theta equal tan inverse 4 divided by 3. So this is the uh, direction of this R. But for easy calculation, we will write, we break into two pieces, 3i and 4j. Now, this is R, this is 5 Newton, and this is theta. I will give tan theta equal 4 by 3. Now, can you break this one into horizontal and vertical components? Can you find the horizontal and vertical component of this one? We know this is going to be 4 and we know this is going to be 3. We did this. So now you want to break, if this is given, you have to break, you need to find the horizontal and the vertical component of it. So how do you do this? Finally, you want to show this is 3 and this is 4. For this direction 3 Newton and this direction 4 Newton. Both are equal 3I plus 4J. Now this is given. Now we need to show this one R equal 3I plus 4J. So then what you need to do, you have to complete a right angle triangle as usual. Let's say this force component is A, this force component is B, then we need to find A and B now. So we know this one, hypotenuse, that is 5. So hypotenuse and this is adjacent. When you come and stand up here, you can see that this is opposite and this is adjacent. So adjacent and hypotenuse is cos. So cos theta equal A divided by R or 5 Newton. So this is R or 5 Newton. You can write everything, anything. So I'll write 5. R value is. Now this A is going to be cos multiply 5 cos theta. Now we found out A is 5 cos theta. Same as this one B. When you come and when you stand up here, you can see this is opposite and adjacent. So that is sine theta. B over 5 opposite. So B equal 5 sine theta. So this is become 5 sine theta. Now if you want, you can write R is 5 cos theta in I plus 5 sine theta j, because this is equal to this one, 5 sine theta. So this is the horizontal vertical component and this is the horizontal component. Now this is we didn't solve properly. Now we want to find cos theta and sine theta. Tan theta is given 4 over 3. So this is 4. If you take this is theta, yes, and this is 3. Then this is 5. 3 square plus 4 square square root 5. Now what is sine theta? Sine theta is 4 over 5. Now 5 sine theta means 5, 4 over 5 sine theta. Now this is 5 to 5 cancel out, 4n. So we found out 5 sine theta means 4n. Now I need this one, 5 cos theta. What is the cos theta now? Cos theta means 3 over 5. Then 5, 3 over 5, 5 to cancel out, 3n. Now this is become 3n. Okay, 5 cos theta equal 3n. Now this is become 5 sine theta. We found out 5 sine theta equal 4n, 4j, and 5 cos theta equal 3i. Can you see this one in a short form? If this angle is given, if this is 5, you know the r, then if you know angle, this is simply 5 cos theta, this one. And this one is 5 sine theta. For example, I have a force here. This force is, let's say, 10, and I will give this is 60. Now I want to break in, this is the particle. I want to break into two components, horizontal and vertical component. So what is this one now? This one is 10 cos 60. What is this one? This is 10 sine. This is 10 cos 60 and this is 10 sine 60. This is 10 sine, meaning this is parallel rectangle. So then this is 10 sine 60. Cos 60 is half. Sine 60 is square root 3 over 2. So this is 5 and this is 5 square root 3. Basically this is 5 Newton and this is 5 the square root 3 Newton. Force is given. You break into two components. So if you need a proof, you can work like this. You can take this is as A and this is B and write the relationship. And for example, if this is A and this is B, cos 60 is A divided by 10. So A equal 10 cos 60. 10 cos 60. And this one B sine 60 equal B divided by 10. B equal 10 sine 60. 10 sine 60. This area is actually in a year 2 area, but I gave a taste of it now to understand this one. So if it look like confused, just wait. We will work with this exercise and then you'll be fine. But I discuss this one because then you know what is really going on. Then it is easy to actually to absorb the theory. In example 3, there are few forces given. One is 2y plus 3j. The other one is 4y minus j. Another one is minus 3i plus 2j. Before, so we'll discuss a bit of these forces. Now, what is the real forces on this particle? Let's say this is the particle. This is x and y. And 2i plus 3j. So what is the magnitude? So this is 2 and this is 3. So this is the theta direction. So what is the size? 2 square 2 square plus 3 square, that is 9 plus 4 square root 13. So this is the force square root 13 Newton. This is the actual one. This one 4ij. This is 4 and this is 1 and this is 4 square plus 1 square. This is square root 17. I will take this is alpha angle. So this is alpha angle. This is square root 17 force. What is this one? 3i minus 2j. So from here to here, 3i 2j. It means to this direction. This is going to be 3 square plus 2 square square. This is the size again. This is square root 13 and this is beta. So beta is somewhere here. So this is square root 13 with beta. This is theta. Now what is actually tan theta? Tan theta is 3 divided by 2. So you know theta value. What is the angle alpha? Uh, Tan alpha is 1 divided by 4. Then you know alpha. What is the beta? Beta is, this is tan beta is, this height is 3 and this is what, 3 divided by 2. So you know alpha, you know size, and so basically this is the forces. So this structure is given in this way. What is this way? So this is 2i plus 3j. Oh, that is for this one. Then for this one, uh, 4i minus j. So this direction minus j, or j for this direction, because direction will give the symbol. And the other one, uh, this one, this one will represent as this one, 3i to this direction, and 2j, it is here. So this is the actual diagram. For easy calculation in this sum, they break and given, so it is easy as to add. So now when we add everything together, we will get the resultant force of this one. So 2i plus 4i plus 2 plus 4, 6, 6 minus 3, 3i. So this is 3 plus 2, 5, 5 minus 4j. So the resultant forces of this system, so I'm not considering the AI and BJ. So 3i plus 4j. So what is 3i? It means 3i plus 4j. Somewhere here the resultant force for this whole system. Or if you draw like this is the same angle. Let's say gamma. Uh, this is gamma. What is the resultant force? 3i plus 4j. What is tan gamma? Tan gamma is 4 divided by 3, y divided by x. So when you work with year 2, they don't give in such a easy way. They will give forces like this, and then you want to turn into this form, and then you want to uh, simplify, and then you want to mark the resultant force here. So this is the process. Now in this chapter, you will get a half of this journey. So they will give like this, and you want to work with half of. But when it's come to year 2, you will get this. So they will straight away give this kind of. They don't give 2i plus 3j 4i. So then you have to find the x and y component, or horizontal vertical component of each and every forces, and then you want to simplify, and then you want to mark. And previously I discussed how to turn this kind of forces into the taking this is 5 and this is 3 and 4. I showed that how to find the components for a given force. Now in example 3, I will consider this is the particle, 2i plus 3j, 2i and 3j, then 4i minus j, 4i, then minus this direction, and minus 3i2j, and other one ai plus bj. So ai plus bj. Now I want to find the resultant force R. So R is, we'll take, or we'll calculate. So 2 plus 4, 6, 6 plus A, 6, 6 plus A, I. Actually, there was a force to this side. Yeah, there is a 1 at, this is 3, uh, minus 3i, 3i. So 2 plus 4, 6, 6 minus 3, 3, 3i, sorry, 3 plus A, I. Then for this direction, 2 plus 3, 5, minus J, 4, 4 plus B, J. This is 1 times minus J. This is 3 times minus I. So you can write minus 3I. And this is minus J. 3 size to minus I direction. And this is 1 size to minus J direction. So this is the idea. Um, without I and J, we can simply mark like this. This is 2, and this is 4, and this is A, and this is 3, this is 2, and this is B, and this is now no negatives, 3, and this is 1. I will stay with this structure, and now we don't need to draw this. Is for you understand 2y plus 3j is given, and 4i minus j, and the next one is minus 3i plus 2j, and other one is ai bj. So we need to find the resultant force. So r equal, we want to add 2i plus 3j plus 4i minus j plus minus 3i. Since it's plus, actually you don't need this one bracket, right, for the safe side, minus 3i plus 2j plus ai plus bj. Then this is become 2i 3j plus 4i minus j. This is minus plus 2j plus ai plus bj. Now we'll take all I components together. 2 plus 4 minus 3 plus ai plus 3 minus 1 plus 2 plus b g. So this will become 3, 4 plus 2, 6 minus 3, 3 plus ai plus, this is going to be 5, 4 plus b g. But given object is in equilibrium, it means R is 0. What is R is 0 mean? 0 I plus 0 j. The components are 0. So then 3 plus ai plus 4 plus bj equal 0 I plus 0 j, because this is r equal to, this is the r value. So r is now 0 I plus 0 j. Now 3 plus a equal to 0 when you compare I components. 3 plus a equal 0. A equal minus 3. And then 4 plus b equal 0. B equal minus 4. When you compare those two, left and right has to be equal. For that, the I component and j component should be equal separately. I coefficients, let's say j coefficients, I coefficients and j coefficients. Now we mark this one a is here, but it is minus 3. It means what is the side of a really? This side. So that is going to be 3. And we mark b is to this side, but it is really this side. It is 4. Now can you see that 3 plus 3, 6. 2 plus 4, 6. It is the horizontal is balance. 2 plus 3, 5. 1 plus 4, 5. Vertical also balance. So both are balanced. It means there is no movement. There is no horizontal movement to vertical movement. It means it is in rest. Example 4. In this question, I represent the vector du east. This is I and this is du I and j. Du north. The particle, so there are some forces given. So we need to find the resultant forces from Pi plus Qj. The question is resultant forces are, we need to find Pi plus Qj. So R equal, you can see that 2I plus j plus 3I minus 2j plus minus I plus 4j. Now 2I, so yeah, 2I plus j plus 3I minus 2j minus I plus 4j. So this is going to be 2 plus 3 minus 1 I plus, this is 1, this is minus 2, this is plus 4j. So this is 5, 4I plus 3j. So what is the p value now? P is 4 and Q is 3. Part 2, work out the magnitude and the bearing. So this is the particle. It has a resultant force R. This R we represent in 4I and 3. So this is 4 and this is 3 Newton. Basically this is also Newton, 3 Newton. So R is the 4 square plus 3 square root, that is going to be 5. 5 Newton, 25 square root, 5 Newton, and Now bearing is measured from here. I need this angle. Let's say this is beta, then this is 4. So you can write tan beta equal, so this is the beta angle, opposite divided by adjacent, 4 equal. So beta equal tan inverse 4 divided by 3. So you will get approximately 53.1. But if you, in case if you find this one, theta, so tan theta equal 3 over 4, then theta equal tan inverse 3 over 4, then you will get as 36.9. So this is 36.9, then you need to find this one, 90 minus 36.9. So then you will get this answer. Now the third describes the motion of the particle. So the particle is going to this direction. So for this direction, the particle will accelerate. So particle will accelerate in the direction of the resultant force. When you apply all the forces, only particle feel this kind of forces. Square root 5 Newton forces to this direction. That's all this particle feels.